Hi there! I'm Gloop, Professor Gloop. I'm a scientist. Do you know what scientists do? Actually, a scientist is just like a detective. Hmm. Hmm. Aha. In order to solve a problem, a scientist searches for clues. Then he or she pieces together all the clues or evidence, and presto, it's solved. A scientist gathers clues by carrying out a series of experiments. All the experiments will follow the same steps or patterns that we call scientific investigation. Come on, let's go over to my lab. That's the place that I work in. Bajuka, majuka, mabubu!
Welcome, Professor.
Welcome to my lab. This is where I carry out all my experiments.
Qu'il faut tirer pour faire. Bien ça, le sélectionner dans l'aéroport en 20 minutes, c'est possible. En 20 minutes, on a le temps de finir mon sandwich.
Hi there!
Hi, Professor.
Do you carry out scientific investigations in school? If you do, where do you carry them out? Okay, let's carry out an experiment and identify all the steps in this scientific investigation. Steps in scientific investigation. All right, let me see. What do we have here? Yes, this is a pendulum. A pendulum has a string and a bob at the end. This pendulum is now in its resting position here. If I pull the bob away from its rest position and I let it go, this pendulum will move from side to side. See, it is moving from side to side, from side to side. We say that the pendulum is oscillating. Do you know what that means? An oscillation means the movement of the pendulum from point A to point B and back again to point A. The time taken for one oscillation is called a period. Do you think we can change the period of an oscillation? Do you think the length of the pendulum affects the period of an oscillation? Well, if you have these questions in your mind, you are on the right track because you have identified scientific problems about this pendulum. Can you make a smart guess as to what the answers to these scientific problems are? If you have made a smart guess based on these problems, you have formed what we call a hypothesis. A hypothesis may be true or it may be false. If you want to know whether your hypothesis is true or false, you have to do an experiment. Let's make a hypothesis. Let me see. When the length of the pendulum is increased, the period of an oscillation also increases. That's the hypothesis. Now, let's do a little test to see whether this hypothesis is true or false. Come on, follow me. Come on. Now, we need to make a plan to test our hypothesis to see whether it is true or not. Remember, our hypothesis says that the period of an oscillation increases when the length of the pendulum increases. Okay, let's plan our experiment. Before we can carry out this experiment, we have to identify and control all the variables involved. Can you identify all the variables involved in this experiment? The length of the pendulum will be the manipulated variable. We need different lengths of string to make it work. The responding variable is the period of the pendulum oscillation. This is going to be the result of our experiment. And the controlled variable is the weight of this bob. The weight of the bob will be the same throughout the experiment. Now, let's identify all the apparatus or materials that we are going to use. In this case, we will need 3 retort stands and clamps, 3 different lengths of string, a meter rule, and a stopwatch. Next, write down a step-by-step procedure. And lastly, don't forget the observation and the measurement to be made. Now, are we ready to conduct the experiment? Are you all geared up? Let's do it!
Yes, sir.
Can you list down what a scientist has to do before conducting an experiment? First, he or she has to identify the scientific problem. Second, he or she has to form a hypothesis. And third, a scientist has to plan the experiment, that is, identify all the variables, determine the apparatus and material, and determine the procedure to carry out the experiment.
Starts to wonder, burning questions fill his mind. He probes on in and under, the answers he does find. Carry out investigations, each steps they follow through. If you want to draw conclusions, this is what you have to do. One, identify what the problem is. Two, form your hypothesis. Three, plan your experiment. Four, your experiment you implement.
Now, we are ready to carry out this experiment.
Oh, sorry.
First, pull the mass 10 centimeters from its rest position. Make sure the stopwatch is ready to measure the time taken by the pendulum to complete 10 oscillations. Then, you have to record all the readings in a data table. This scientific step is called collecting data. Okay, ready? Get set and go!
"18 seconds."
It seems that this pendulum needs 18 seconds to complete 10 oscillations. Don't forget, my friends, you must record all the readings in the data table. To ensure the results you get are accurate, you have to repeat the test at least 3 times and calculate the average of the 3 readings. Now, let's repeat the experiment. Remember, this is our second try.
"17 seconds."
Strange. This time, the time taken is only 17 seconds. Let's do it once again and see if we will get a different result.
19 seconds.
19 seconds?
19 seconds?
Okay. Can you calculate the average of the 3 readings? Let me see now. This pendulum needs 18 seconds to complete 10 oscillations. Now, can you calculate the period of oscillation of this pendulum? The period of an oscillation for this pendulum is 1.8 seconds. Now, let's observe whether the other 2 pendulums also have the same oscillation period.
"21 seconds." "21 seconds." "21 seconds."
Well, the average time taken for the 30 centimeter pendulum to make 10 oscillations is 21 seconds. It means that the period of an oscillation for this pendulum is 2.1 seconds each. the period of oscillation for the 30 centimeter pendulum is higher than the 15 centimeter pendulum. What does this mean? It means that it takes a longer time. Can you guess what the period of an oscillation for the 45 centimeter pendulum will be? Do you think it will be higher or lower than the two pendulums before it? Let's observe.
Twenty-eight seconds. 29 seconds. 27 seconds.
The average time taken for the 45 centimeter pendulum to complete 10 oscillations is 28 seconds. This means that the period of an oscillation for this pendulum is 2.8 seconds. That's interesting, isn't it? What do you think will happen if we use, say, a 10 centimeter pendulum or perhaps a 100 centimeter pendulum? Let's take a look at all the data that you have collected from the experiments. When you record your readings into a data table, you will see that the data follows a certain pattern or sequence. Sometimes the pattern will become clear if you organize the data in a graph. This step is called analyzing and interpreting data. Hey friends, can you make any inference from the data we have collected? From the data, we can see that the period of an oscillation is not the same for pendulums of different lengths. What else can we learn from the data? Come, I want to show you something. We can also find a relationship between the two variables that we have identified before. Let's connect all the points plotted and draw a line graph to see if we can find something interesting about the data. Well, can you see the line? Do you know what it means? It means that the length of the pendulum affects the oscillation period of the pendulum. So that means the conclusion of our experiment is when the length of the pendulum is increased, the period of an oscillation also increases. Hey, do you know what that means? It means that our hypothesis is true and can be accepted. Yeah, what a terrific day. Wait, where do you think you're going? Hey, we haven't completed our scientific investigation yet. We still need to write a report. Making a report is the last step in a scientific investigation. And just what do we write in our report? We write all the procedures, information, and observations from the experiment. This report will allow other students to share the results of our experiment. Wouldn't that be interesting? So, this is how a group of scientists communicate among themselves. Now, let me tell you what you should have in your report. You should have the date of the experiment, the scientific problem identified, the hypothesis, the materials and apparatus, the method or procedure, the data collected, the precautions to take, if any, and finally, the conclusion.
wonder. Burning questions fill his mind. He probes on in and under till the answers he does find. Carry out investigations. Each steps they follow through. If you want to draw conclusions, this is what you have to do. One, identify what the problem is. Two, form your hypothesis. Three, plan your experiment. Four, your experiment you implement. Five, collect the data from all around. Six, analyze what you have found. Seven, think and make your conclusions. Eight, report your investigation.
La 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 la. Questions!